with the ejection of billions of microscopic droplets of lambda nano ink onto the special image conveyor blanket. Each row of ink ejectors adds its own color of nano ink. Each droplet of nano ink lands at a precisely designated location, blending with other droplets to create the final colored ink image. As each droplet lands on the heated blanket, it begins to spread and lose its water, becoming thinner as it does so. When all of the water has been evaporated, the ink becomes an ultra-thin, dry polymeric film. Let's look again. As the nano ink film spreads and dries, it becomes only 500 nanometers thick, the thinnest ink image of any printing process. The completed image is now ready to be transferred. Because of its unique properties, nano ink images have the amazing ability to bond tenaciously to any paper or plastic without penetrating the substrate. Upon transfer, the nano ink film instantaneously bonds to the paper, forming a tough, abrasion-resistant laminated layer, leaving no residual ink on the mark. Nano ink images can be transferred to sheets or webs of ordinary coated or uncoated paper or plastic packaging films without any kind of pre-treatment. Since nano ink images are already dry, there's no need for any kind of post-drying, so two-sided printing becomes simple and printed goods can be immediately processed right out of the press. So, now that you've seen how the nanographic printing process works, I'm sure you're curious as to what the print looks like. So we are now going to compare the offset printed dots with which you are all so familiar with inkjet printed dots, with nanographically printed dots, and in this case, all on plain, ordinary, uncoated paper stock. Offset printed dots have poorly defined edges and non-uniform density. Inkjet printed dots are even more ragged with poor optical density. And this is nanography. Note the extraordinary edge sharpness, high image density, and uniformity. Such a startling effect deserves a more in-depth explanation. You see, as the ink penetrates the paper, much of the pigment ends up below the surface, reducing optical density and uniformity. And just as ink gets absorbed into the paper fibers, it also wicks along the paper fibers, making the edges ragged. With lambda nanographic printing, a dry ink film is applied to the paper, so there's no penetration and the edges are super sharp. Since these ultra-thin film images are literally laminated to the paper, they conform to its surface roughness, right down to the topography of individual paper fibers. This accounts for nanography's extraordinary ability to match the gloss of the paper, whether coated or uncoated. Unlike conventional inks, in which the pigment particles are many hundreds of nanometers in size, lambda nano ink pigments are merely a few tens of nanometers. These nanopigments are not only super efficient absorbers of light, but they also don't scatter light. These properties give lambda nanographic printing the broadest CMYK color gamut of any printing process. So, what we have seen so far is that the thickness of the ink has a profound effect on the properties of the printed page. And thinner is better. But thinner is also better in one other respect. The thinner the ink image, the less material it takes to produce, and therefore the less it costs. This comparison shows you the relative thicknesses of various printing processes and gives you insight into why Landa nanographic printing is the lowest cost printing process of any digital process. Now, many have said to me, why did you develop nano ink based on water? Why not, for example, solvent or UV? And the answer is very simple. Even if our customers could afford them, our planet cannot. And that is the reason that Landa nanographic printing is based on pure, clean water. Environmentally friendly, plentiful, and certainly very cheap. And now, ladies and gentlemen, it is my great pleasure to give you a brief introduction into the full line of Landa nanographic printing presses. The Landa nanographic press lineup comprises 3 sheet-fed presses and 3 web presses, spanning the entire range of commercial printing